Good morning, folks. Welcome back to another Chima Restaurant and Chop House video. This is Cole coming at you today. Today we're going to be working on the law of cosines. And for the first problem, it says, for example 1, find BC if C equals 5, angle A equals 90, and B equals 3. For the law of cosines, we use the equation A squared equals B squared plus C squared minus 2 times BC cosine of A. For the first example, it says, find BC if C equals 5, angle A equals 90, and B equals 3. So for this equation, we're finding BC, which is here, and we use our given sides and angles to plug it into the equation A squared equals B squared plus C squared minus 2 times BC times cosine of A. So as you can see, I plugged in the given sides into the equation. Now we solve. As you can see here, we end up with A squared equals 34. Since there's no square root of 34, we take the square root of both sides of the equation. Alright, as you can see, we can't do anything with this answer right here, so we leave it, and that's our answer for the first example. Alright, now on your own, try the practice problem, which says find AB if A equals 4, B equals 3, and angle A equals 100. For this practice problem, we're actually going to go back to law of sines and use law of sines to find angle C. So we use sine 100 over 4 equals sine B over 3, and that comes out to be 48 degrees. As we find 48 degrees, we also need to find angle B. We subtract 180 minus 100 plus 48, which is 148, to get 32, which is our third angle. Then after finding the third angle, we do law of sines again to find side C. We do sine 100 over 4 equals sine 48 over C. This comes out to be 3. Cole Rigney here from Chima Restaurant and Chop House, coming at you with the second practice problem. And today for the second practice problem, we have, for example, solve triangle ABC if A equals 4, B equals 3, and C equals 5. Alright, so for this problem, we're working with 3 given sides, so we use the equation C squared equals A squared plus B squared minus 2 times A times Bill Bickley cosine of C. Alright, now we are going to plug in the given sides into the equation. I'm just going to erase this for a little more room. We have C squared equals A squared plus B squared minus 2A Billiam Bickley cosine of C. As we plug them in, we know that C equals 5, A equals 4, and B equals 3. So now 5 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 cosine of c. 5 squared is 25 equals 16 plus 9 is 25 minus 24, 2 times 4 times 3 cosine of c. Now as we subtract 25 from both sides, we get 0 equals negative 24 cosine of c. As we divide by negative 24, you can see that we get 0 equals cosine of c, which is cos negative 1, so cos negative 1 of 0, which is equal to 90 degrees. Alright, so now that we know that angle C equals 90 degrees, we come over to this side, we write 90 degrees, angle C. Now, we can redraw our triangle. Angle A. But now we know one of the angles, which is C. So this is 90 degrees. So if we know one of the angles, now we can use law of sines to find that sine 90 over 5 is equal to sine B over 3. So we get 3 sine 90 over 5 equals sine of B. Sine negative 1 of 3 sine 90 divided by 5 comes out to be 37 degrees, which is our angle B. Now that we know two of the angles, we can subtract both the angles from 180. To find out that the last angle is 53 degrees. Now try this practice problem on your own. Alright folks, use this to check your answer for the second practice problem. Alright folks, today we're working on example 3, where it says solve triangle ABC if angle A equals 40, B equals 3, and C equals 5. So as you can see, I drew the triangle, and we're going to use the formula A squared equals B squared plus C squared minus 2 times BC cosine of A for this equation. So as you can see, I plugged in the given numbers into the equation. And now we solve. So as you can see here, there's no square root of 11, so we take the square root of both sides of the equation, and we get A equals the square root of 11. So we put square root of 11 here, and now we can use the law of sines to figure out the other angles. So as we do sine 40 over root 11 equals sine C over 5. So as you can see, we can't have a square root on the bottom, so we turn it into a decimal, which is 3.3. So sine negative 1 of 5 sine 40 divided by 3.3 turns out to be 77 degrees. So C equals 77 degrees. So now we subtract 77 and 40 from 180, and we get 63 as our third angle. All right, folks, for the third practice problem, we're going to solve triangle ABC if angle A equals 50, B equals 4, and C equals 6. Try this on your own. Use this to check your answers for the third and final practice problem. Thanks for watching.
On three.
On three.
1, 2, 3.
Thanks for watching.